Hello everyone, my name is Kevin Fisher and I work for Geosoft Africa as an account executive. I have the pleasure of welcoming you to Geosoft Africa's first webinar entitled Maximizing Potential Field Data for Energy Projects in Africa, presented by my colleague Carla Gombrink. Although the use of potential field methods, gravity and magnetics, is not new to energy explorers, recent years have shown a marked increase in the use of these methods, especially so in Africa. Frontier regions in Africa can have acreages in the region of 15 to 20,000 square kilometers. Often explorers only have a window of 5 to 6 years to make a decision regarding relinquishment or further development. Non-seismic methods mitigate this risk, providing a cost-effective, safe and environmentally friendly way to delineate and define basins within these large frontier acreages. Through a planned series of webinars covering the mapping, modeling and interpretation of gravity and magnetics, we will demonstrate the value and effectiveness of utilizing potential field data. Carla, over to you.
Thank you, Kevin, and good afternoon, everyone. I'm glad you could join us. Before I start, I would just like to mention that this is the first webinar we are running from our South African office, and we're still testing the technology. Please bear with us if there is any lag or other technical hiccups. So let's start with this introduction to mapping, modeling, and interpretation of potential field data. In today's competitive energy marketplace, oil and gas companies face a growing demand for hydrocarbons and increasingly challenging exploration targets. There was a time when gravity and magnetic surveys were considered the coarser, rougher first cut to find the best locations to do seismic surveys. That's all changing now. Increasingly, gravity and magnetic methods are being used to complement and constrain traditional seismic data, or even used as the only tool. Grav and mag data quality has improved significantly over the last few years. Not only can we acquire data more quickly now, but also our data resolution is much better, and we can now resolve more subtle variations in both the gravity and the crustal magnetic fields. This improved resolution now allows us to image very small scale and shallow lateral variations in density and magnetic susceptibility. These are often associated with the hydrocarbon play itself. Modern GravMag surveys can now provide a set of observations that is more directly associated with hydrocarbon play character, in addition to the traditional regional information for which we have long used potential field data. Also in recent years, significant technological advances have been made. These include in acquisition, airborne gravity gradiometry, which provides a rapidly acquired high-resolution image of local gravity anomalies, and in software development, improved 3D inversion algorithms for sophisticated gravity and magnetic Earth models, as well as cloud-based computing. With this in mind, we'd like to share with you Geosoft's range of gravity and magnetic mapping, modeling, and interpretation solutions for oil and gas exploration. With the gridding, filtering, modeling, depth debasement, and other capabilities of Oasis Montage and GMSys, you can optimize your analysis and visualization of gravity and magnetic data and integrate this information with interpretations derived from geologic, seismic, and other data. As a result, you maximize the accuracy of your final interpretations and minimize the number of potential targets that require expensive exploration methods such as seismic reflection or drilling. Today we'll be looking at a brief overview of these solutions as I walk you through a typical exploration workflow, integration, mapping and processing of potential field data in Oasis Montage, followed by modeling and interpretation in both 2 and 3D, and finally looking at management of exploration data. So let's start with Oasis Montage. This is a robust and comprehensive geoscience mapping and processing system and an industry standard specifically for geophysical datasets. We've always understood the need for building knowledge and creating better interpretations from large volumes of data, and Oasis Montage provides you with an optimal environment for integrating, viewing, and comparing large volume geophysical, geochemical, and geological data. It accelerates the data analysis required to support effective daily problem solving and decision making in large oil and gas initiatives. First, I'd like to look at some more general capabilities of Oasis Montage. One of the key factors is the performance of the Geosoft database. A Geosoft database can store and handle over 1 billion points of data per channel per line, making it easy to process, integrate, and visualize data at each stage of your project lifecycle. Also, the dynamic linking function provides the ability to highlight a single data point and see the position of that point on other maps, on the database profile viewer, and on 3D views. This becomes very handy if you want a quick and efficient way to interrogate and interactively edit your data and to evaluate potential prospect selections more quickly. It also provides seamless integration with Esri. You can view and manipulate your ArcGIS MXD files directly in ACES Montage, import and export shapefiles, and you can also produce professional quality maps. The projection engine provides on-the-fly projection and can handle over 2,000 datums and projections. This is very handy, for instance, if you have historical data sets that you want to compare with recent survey data that have different projections. Our dynamic linking feature that I mentioned earlier can handle multiple maps and databases in different projections. Geosoft provides a wide range of 3D functionality and has also taken this functionality to the ArcGIS platform. It enables you to visualize all your data, including geology, geophysics, and geochemistry, in a single 3D environment. Next, we will look at some of the ACES Montage extensions specifically useful and geared towards oil and gas. First off, we have the Geophysics extension. This extension provides a range of filters and statistical tools for working with large volume geophysical data. There are numerous 1D space domain filters as well as Fourier domain filters, which can be applied to potential field or other data. A variety of geostatistical tools provide the ability for summary and advanced statistics like histogram, scatter, and tripod analysis, for instance. The MagMap filtering extension provides a 2D FFT filter library to allow the application of common Fourier domain filters to gridded data in ACES Montage. MagMap rapidly processes and enhances gridded data sets by applying a wide range of geophysical and mathematical filters. This is useful, for instance, for identifying and separating regional and residual signals within the observed gravity and magnetic data sets. The GravMag interpretation extension includes Euler 3D deconvolution processing routines to automatically locate and determine depth for gridded magnetic and gravity data. Euler 3D automates 3D geologic interpretation by delineating magnetic and gravimetric boundaries and calculating source depths. There's a source edge detection tool included for locating edges, for instance geological contacts, or peaks from potential field data by analyzing the local gradients. And the source parameter imaging tool quickly and easily calculates the depth of magnetic sources. Profile depth debasement is an automated application for determining the position, orientation, and intensity of susceptibility of magnetic source bodies along a magnetic profile. It's commonly used in the oil and gas industry to map the shape of and depth to magnetic basement. With large distinct density contrast, you can also use P-depth to determine the position of gravity source bodies. The geophysical techniques used for determining the depth to the basement include Wiener deconvolution, analytic signal, and extended Euler deconvolution. After you've done sufficient processing on your data, you will move on to modeling and interpretation. So next we'll look at GMSys profile modeling. This is a user-friendly, interactive gravity and magnetic modeling program that enables you to rapidly create a geologic model and test its accuracy by comparing the model's gravity and magnetic response to observed measurements. It allows for rapid model creation using a starting model wizard, importing models from numerous formats, or automatically create models from digitized geologic images. There are quite a few areas in oil and gas exploration where GMSys is very useful. It could, for instance, be used to create a sensitivity model. In certain geological settings, gravity and magnetics won't work. Using GMSys to construct a theoretical model to test the sensitivity of the tool in a particular geologic setting will help you determine whether it's even worthwhile to do a gravity and magnetic survey. If your results indicate that gravity and magnetics will give more insight, the data can be acquired, and GMSys can then be used to build a constrained Earth model of the surveyed data. You can test your model's accuracy by comparing the model's gravity and magnetic response to observed measurements, as you can see on this slide. Observed measurements are in green and the model response is in black. It's important to note that gravity is correctly characterized as a low-resolution geophysics exploration tool. Without constraining information, a gravity model can be modified in an infinite number of ways in order to match the observed gravity signal. Seismic, well log, and other geologic data provide critical constraining information for gravity models, limiting the degrees of freedom of our modifications and enabling us to produce a meaningful, constrained Earth model that is consistent with both gravity and seismic data sets. With that in mind, I'd like to mention that there are a wide variety of industry standard data formats that can be imported into GMSys. You can place SEG-Y, bitmaps, and other images in the background of your model, import seismic and other horizons, wells and well markers, configurable LAS well files, and numerous other file types as you can see on the current slide. You can also export surfaces or entire models to many other programs. Another handy feature is that you can add a time window below the standard depth window. You can then load seismic time sections, build models in time using all of the GMSys tools, assign velocities, and convert the time model to a depth model. Changes made in either the time or depth windows are immediately reflected in the other window. Finally, GMSys Profile is completely integrated with GMSys 3D, OASIS Montage, and the Montage extensions. The dynamic linking functionality will help you to use GMSys with OASIS Montage to create fast, well-constrained, and presentable interpretations. GMSys 3D is next in line. It is an interactive layer-based gravity and magnetic modeling program that enables you to design 3D models that accurately depict the variation and irregularity of subsurface structures and calculate your model's gravity and magnetic responses. The user-friendly interface provides easy model creation, visualization, manipulation, and constraint. With GMSys 3D, you can create insightful 3D models by integrating gravity and magnetic and seismic data, plot 3D displays of the model in one simple step, and 3D visualizations update automatically during inversion and structure editing. You can add wells, seismic sections or volumes, or other vector or raster information to the 3D model visualizations. Another important feature is the joint inversion. Better understand your subsurface geology with full tensor gravity gradient joint inversion, and jointly use any combination of gravity gradient tensor components plus magnetic and normal gravity to constrain the inversion. You can import and correctly place images, seismic bitmap, cross-sectional balancing profiles, geological sections, and so forth that can be registered in OASIS Montage and many other programs. I want to stress again the importance of integration of different techniques in oil and gas exploration. Seismic data quality is not uniform in all geological settings. Due to their elastic properties, some rock pathologies do not readily transmit acoustic energy. Seismic signal can be attenuated, and you will struggle to image below these acoustically challenging horizons. If there is a significant lateral density variation below the problematic acoustic horizon, gravity can provide unique information about these rocks, since gravity is not negatively impacted by rock elastic properties. Another common imaging problem for seismic data is a near vertical fault or interface like a salt or shale dye pier. Seismic signal is typically scattered by these interfaces, while in contrast both gravity and magnetics have their best imaging at vertical interfaces across which a lateral density or magnetic susceptibility contrast exists. But seismic techniques remain indispensable. Precious few oil and gas discoveries are made without the use of seismic methods. However, other geophysical methods can assist with more reliable evaluations in these deeper, more challenging environments. Gravity and magnetics will never entirely replace seismic. They'll continue to be complementary tools. We've recently improved the GMSys 3D interface and architecture to make it easier to build robust Earth models. We call this VALEM, or voxel-assisted layered Earth modeling, which is a technical solution that optimizes the use of gravity and gravity gradient data for more effective modeling and characterization of subsalt environments. Combining the ability of the GMSys 3D modeling platform to import and build models from your seismic workflow with Geosoft's Voxy cloud-based geophysical inversion service. Just to mention Voxy, it's a powerful, scalable, cloud-powered solution for geophysical 3D inversion modeling. The service has been running for a number of years, and it has grown quite rich in its capabilities, especially in the ability to constrain inversions. The Voxy Earth modeling engine is an integral element of a volume solution. Our hybrid calculation method is computationally efficient since it permits both frequency domain and space domain calculation on different elements of the model for optimum performance. Cloud-based server strategies make the space domain calculation methods practical for exploration-sized models. I'd like to just take a moment to explain the elements of this hybrid model I spoke about. The three most widely used data structures used for representing 3D models are grids, triangulated surfaces or geosurfaces, and then 3D voxel grids. Grids have obvious advantages for representing single-valued surfaces, but are difficult to use for representing multi-valued surfaces, such as the boundary of a complicated salt body. Triangulated surfaces work well for representing complex bodies of constant density, but are clearly inefficient for representing large, complicated volumes that vary in all three dimensions. Voxels represent this latter situation well, but suffer from large increased calculation expense and quantization errors, in other words limiting on the vertical size, particularly near the observation location. Our 3D modeling strategy has added the ability to use all three of these structures within a single model. Single grids will define layer boundaries, such as a sea bottom. You'll be able to define more complicated structures with our added support for geosurfaces that define more complex geometries. And voxels add geologic realism by importing your seismic velocity data to define 3D density distributions. So what can you do with volume? Well, we've been working to improve your ability to explore subsalt plays to identify and drill subsalt prospects cost effectively. Base of salt is an important petroleum trap in exploration prospecting for oil and gas, and accurate representation of base of salt in subsalt environments has a major impact on selection of drilling locations in these environments. The challenge is that these environments are difficult to image with seismics due to the highly reflective top of salt. Interpreting top of salt structures is a relatively simple process due to the low density of high seismic wave velocity of salts. Gravity inversion and modeling techniques are utilized to improve base of salt and subsalt imaging, where interpretation based on seismic data alone is challenging or impossible. These techniques will help to eliminate uncertainty during the interpretation and target selection process, reducing risk and cost when advancing oil and gas exploration programs in subsalt regions. Volume will be available via an early adopter program in August for customers interested in using this technology prior to its release, which will be somewhere later this year. Lastly, we'll have a brief look at data management. Geosoft DAP is server technology for publishing, distributing, and discovering exploration data. With DAP, data is secure, organized, easily accessed, and shared amongst all the people that need exploration data to make decisions. Geosoft DAP Server enables exploration organizations to efficiently catalog, manage, deliver, and visualize large geospatial data. It makes your data instantly accessible and shared amongst all the people and teams that need exploration data to make these decisions within the organization. This is achieved from a single interface deployed within the geoscientist interpretation platform of choice, either Oasis Montage, ArcGIS, MapInfo, or any web browser. You can manage and deliver active and historical data, including geology, geophysics, geochemical, and GIS, while supporting metadata preparation and management. And it's able to efficiently catalog and deliver a broad range of data file types, including very large geospatial grids, 3D voxels, images, and vector data. Adding data to DAP is simple. You edit it in your digital mapping environment, add metadata, and then submit it to the DAP server. This can be done via one of the platforms I just mentioned, one of our Geosoft products like Oasis Montage, or MapInfo, ArcGIS, or any web browser. Extracting data from DAP is just as easy. You select your project area, search and browse all the available data sets, and finally preview and download the selected data to your interpretation software. There are also various free data sets that are accessible through the DAP server that are useful in oil and gas exploration, including bathymetric and elevation data and regional gravity and magnetic data, as can be seen on the current slide. If you're interested in any of these data sets, we can send you the links where to download them. Just let us know either by typing in the Code to Webinar question section or send us an email afterwards. That's it from my side. I thank you for listening. Before I hand over to Kevin again, We would like to ask you to let us know what your experience of the webinar was. Did you have trouble installing the software? Is the interface user-friendly? How was the audio and visual quality? Was there any lag, and so forth? We'd appreciate your feedback so that we can improve on any issues there might be for the upcoming webinars. Back to you, Kevin.
Thank you, Carla. We appreciate your participation in an online poll. Your input will help us plan and prioritize content for the follow-up seminars. The follow-up seminars are based on the slide presently showing. We plan to take you through your non-seismic data workflow, first focusing on the qualitative interpretation of GravMag data using Oasis Montage. The focus will then shift to the quantitative interpretation of your GravMag data using profile and 3D modeling technology. Lastly, we will look at how to manage and disseminate this data, both from a technology point of view and through advancement of local skill sets. Another question raised was, will the format of the upcoming webinars take on a more hands-on approach? If so, when do you plan to start the follow-up webinars? Good question, thank you. Yes, we will be accessing the respective programs and technologies live during the series of future webinars. The presenter will work through practical examples for illustrative purposes. We plan to start the follow-up webinar series in a month's time. Another question raised was, you make mention of cloud computing or services during the presentation. How secure are these services? Just getting some notes together. I should have a response. There's quite a bit of technical information on this. The service you're referring to is called VALM, and I think Carla mentioned that it stands for Voxy Assisted Layered Earth Modeling. It's scheduled for release in the last quarter of 2014. And as the name suggests, it leverages on our proven existing Voxy services. Bear with us. Let's have a look. Sorry, I'm getting interference. Basically, your data files are secure when using Voxy. Within Voxy's secure service infrastructure, files are encrypted and sent via SSL to Microsoft Azure. And that's in a state of, these are state-of-the-art services. There's a lot of acronyms here, but basically there's a lot of encryption and security on it. For those people that raise these questions, or to the individual, we'll send you some more information via email regarding the architecture. We will now close the poll, and we hope you have had the opportunity to make your selection. That brings us to the end of today's webinar. We thank you for your input, and we look forward to your participation in our next webinar. Thank you and goodbye.